Hello everyone, and welcome to our video on present value of an annuity and amortization. So I have two problems here in this video. What we're going to do is use the TVM solver. This is the equation if you wanted to try it out. So some of these variables were introduced in previous formulas if you're watching other videos, but we still never use the formula because the TVM solver is a lot faster. And with all the TVM solver problems, it's just whenever you see something is compounded, or if there's some type of monthly or quarterly or periodic payment. And so the variation that occurs in these style problems is that we have a present value of something that we would owe money on. So for example, like car loans, student loans, home loans, credit cards, etc. Okay, so these are usually larger sums that we owe money to, and we pay it off slowly with payments usually every month or so, but we also will be paying off interest, so it's a little bit of a double whammy. Okay, anyway, let's see how it works. So in this example, it says to help pay off a credit card, Ricky's company suggests that Ricky pays $100 monthly for 5 years at 2% compounded monthly. All right, so just right away there we see the compounded, we see the pays monthly. Okay, so instantly we have the TVM solver, and I just use the TVM solver online. So 83, 84s, Inspires, those types of calculators have them too, but this one is free and right away available on a computer, so that's what I'm using. And even the 83 or 84 looks kind of like this, and I like this one, the GeoGebra. Kind of tells you what's going on with those, but we will be entering the numbers here as we go. All right, so just to move it to the side for now. So first thing though, as soon as I see compounded and the monthly payment type stuff, I know all of these letters are important to us, all these variables, so I'm going to copy them. So we have our in equals I% equals present value equals payment equals future value equals payments per year, or the number of times compounded per year. So that's what those are. These should always be the same, or at least in all of our problems. Sometimes they could be different, but most of the time they are the same. Usually a monthly payment and a type of compound are the same, or the same time period. I keep saying monthly. Monthly is usually the common one. And then the other thing that we do have to remember is that capital N is the number of times compounded per year times time. Okay, so it's both of those just in case. All right, and so let's start to fill this information. It says to help pay off a credit card, Ricky's company suggests that Ricky pays $100 monthly. All right, so that is the payment. So we'll use negative 100. So usually we use negatives for outgoing. So this is out of Ricky's pocket is what he's paying. So that's why it's considered outgoing. And then it says for 5 years, the monthly part we could take care of. That would mean those are each 12. Okay, so the monthly is both the payments per year and the compounds per year. And then we see the 5 years would be time. So that means we could do 12 for the compounds per year times 5 for the number of years for capital N. And then it says 2%, that's our I%, so that's 2. Remember, don't change that decimal, just leave it as the percent, 2%. And then compounded monthly, well, we already took care of that. And then it's asking what lump sum could Ricky pay to equal the present value of the company's suggestion. Okay, so it's asking for the present value. Even with the lump sum, we could figure out that it's present value from that too. All right, so that's what we'll find. So we'll use 0 as a placeholder, and so this is what we're finding. The future value would hopefully be 0. Okay, so because we're trying to pay it off, so 0 would go into that place. And then now we can find the present value by using our TVM solver. Okay, so in our TVM solver, we've got 12 times 5, and it does it for us. It's 60. And then we have 2. And then our present value, we'll use 0 for now as a placeholder. Payment, negative 100. Future value, 0. And then the payments per year and the compounds per year are each 12. Okay, and then on this, it lets us know which one to solve for. We're solving for present value, so we'll click it, and there we go. Okay, so and that's rounded to the nearest cent, so we have $5,705 and 24 cents. Okay, so there we go. So that is that lump sum that he could pay right now to pay off, assuming that's how much he owes, to just pay off the whole credit card instead of paying interest on the credit card each month. Okay, but that is the large sum, and that's what could be difficult. So often we can't do that. Okay, so when we do have to break it down slowly. Okay, so on number 2, it does ask how much would Ricky spend in the 5 years and how much interest would be paid. Okay, so the amount spent would equal the number of payments that were made, or the amount of the payment, the amount of the payments times the number of payments. So it is just your payment times your in. And on this is where we would just use positive 100. So we would have positive 100. The in was 60. 12 times 5 was 60. And so we can see it's $6,000. Okay, so there's our amount spent. And so then we can figure out the interest. The interest is that amount spent. Let's just say spent to, oops, I freaked out. Spent to just abbreviate. Minus the present value, so minus what could have been paid right away. And so we would have $6,000 minus the $5,705.24. And then from here, we would use a calculator again. So I'm just going to use the most basic one here on the computer. So 6,000 minus $5,705.24 gives us $294.76. Okay, so $294.76. Okay, so not too bad. So it's like almost about $300 kind of extra spent. That interest rate was kind of low, though, for something like a credit card. Often credit cards are insane interest rates, and so you never want to accidentally spend too much. And what we could do is, well, let's see it. So this is sort of lifelike here with Donovan. All right, so let's see. So it says Donovan charged $3,200 on a new credit card. He then realized that the card's interest rate is 24% compounded quarterly and stopped charging to the card immediately. He plans to pay off the account by the end of 2 years. What quarterly payment must be made to amortize the loan? So amortize, so they're going like Latin on us. So they're going old school. This means to kill. So what quarterly payment must be made to kill the loan? Okay, so that, which also eventually means to make the loan $0. Or just maybe $0 loan is weird. What we're doing is paying off the loan. Paying off the loan entirely. Okay, so we've got, so that's what amortize means. Okay, so it means to just pay off whatever. All right, so let's break it down. Again, I see compounded right here. I see payments I know are TVM solver then is going to be used. So N equals I% equals present value equals payments equals future value equals, and then our payments per year, and then our compounds per year. All right, and then now let's see. So it says Donovan charged $3,200 on a new credit card. He then realized that the card's interest rate is 24% compounded quarterly. And remember, you can fill these in any order that you want. So, for instance, like the 24% is easy. And then compounded quarterly, that would be the payments per year and the compounds per year. Because, again, they're the same number. And it says it down here as well, the quarterly payment. So we know it's quarterly again, so 4 and 4. And then even there, you can put 4 into the in and then leave a parenthesis. Eventually, we need to put time also in there. Okay, so we've got some of it set up. It says he plans to pay off the account by the end of 2 years. Okay, so there's the 2. And then it's asking what quarterly payment. All right, so that means we're finding the payment. Must be made to amortize the loan. So to amortize the loan, we would say, hey, the future value should be 0, so in the future we should pay nothing. All right, and then now the present value. All right, so this Donovan charged $3,200 on a new credit card. That is the present value. So that is what he presently owes to the card or to the company. Okay, and so we'll go ahead and do a negative 3,200. In the last problem, so the negative is just kind of the way the calculator is programmed in the TVM solver. On this last problem, so just kind of real quick back to this. So all the TVM here. Here I used a payment of negative 100. If I did positive 100, it's going to just change it to negative there. Okay, so all it's doing is just making sure these signs are opposite. So it's treating, it would be treating the payment as the negative would be the kind of more real thing we would do. Okay, so, but it doesn't matter. It's the same numbers, just with opposite signs. So it doesn't matter which one you do. Okay, so on here, I'm choosing to do the negative 3,200 as a present value. And it's not going to change the absolute value of the answer. Okay, but anyway, let's go and plug everything in. So 4 times 2 is 8. And then we have 24%. This I'm saying is that negative 3,200. Payment 0, future value 0, payments per year is 4, and then the compounds per year is 4. And then we wanted the payment, so click that. There we go. And then just to show one more time, if I did choose the present value to be positive, then this is the same number except it's negative. And then our answer still would be, well, we would make it positive for a final answer because we usually don't say it like that in words in real life. So we say we would pay this $515 every quarter or whatever it is. Okay, so there we go. So we do have it. So the payment is $515.32. Good. Okay, so just making sure I wrote the right decimal down. Right there. Okay, so that's it. That's all I wanted. So what quarterly payment must be made to amortize the loan? We found it. Okay, so about $500 each month or each quarter for 2 years, and that should pay it. All right, well, anyway, for now, we'll put a pause. I've got 2 more problems. We're going to do those on a different video, though, so take a break. If you want to try them, I mean, you can pause it right now and try them out, and then come back to the next video and check the answers. But it is very similar to what we did here. Okay, so if you do have questions, though, please let me know. Otherwise, thanks for watching, and I'll see you.